Hey there, everybody. Welcome back. We're working on applications for systems of equations. This is 7.4 in John Blakely's textbook, johnblakely.com. Applications for systems of equations. And like we did before with word problems, I'm going to end up using a table. Problems you see in this section often have, again, moving objects. So rate times time equals distance. R times T equals D. You will see mixture problems. One application is money. This has like the amount times the cost or price equals total value. And we can actually have percent problems. There's a lot of these. And this is amount times percentage rate equals the quantity. So let's just dive into some word problems. Applications is synonymous with word problems, everybody's favorite topic in mathematics. But let's be honest, the hard part there is turning the math or the words into math. It shows you why we need math. So a store sells, some of these are a little contrived, but let's say a store sells 45 shirts at $8.50. A store sells 45 shirts. Some are marked at $8.50. And the rest are at $9.75. $9.75. The store made $398.75 in sales. How many of each type of shirt did they sell? Now, this one actually isn't all that contrived. This can happen. It can happen kind of easily if you sell at a swap meet or something, and you're selling stuff like that. Some stores, some like small mom. I worked for a small clothing company that didn't have very many styles of shirts, and the style, there's a lot of colors in each style, but like there wasn't very many styles. And it's, if you're selling a bunch at like when they would go to like farmer's market or something like that, or attend like a swap meet or something as they were getting started, it's easy just to make the sale and not record what type you sold. But for inventory purposes, you kind of want to know later on. So let's call them shirt X and shirt Y. And the letter will be like how many they sold. So maybe we sold X of shirt X and Y of shirt Y. And the rate is, we'll make the X one the cheaper one, the 850, and the Y one is the 975. And so total, well, the total value for each one would be, this would be 850 times X, and this would be 975 times Y. Now I do know we also have a total along the bottom. They sold 45 shirts. Having a total for rate doesn't make much sense, but a total sales does. And we saw that they sold $398.75. these two had to add to 45. The total number of shirts should add up to 45. And the total for the total values should add up to this total sale price. So 850X plus 975Y equals 398.75. I think this is a good problem for substitution. I will subtract X here, and I get Y equals 45 minus X, which I will put there. I don't know what that equals. 975 times 45. A lot. So I have 850X plus 438.75 minus 9.75X equals 398.75. So I'm going to combine these two while I subtract this. On the right side, I get negative 40. And 8.5 minus 9.75, I think it's negative 1.25. I get negative 1.25x over here. So I'll divide both sides by negative 1.25. And I get x equals 32. I will take that and I will plug that in up here. 32 plus y equals 45. Y equals 13. So for the $8.50 shirt, at $8.50, they sold 32 shirts. At $9.75, they only sold 13 shirts. And you can check that by sticking those in and checking them in each equation. Here I want to give you a sampling of this kind of stuff. All right, so let's do the next problem. A store sells, I already did that one. 10 liters of 30%, I wrote then 10 liters of 30% acid is made by mixing a 20% solution and with a 50% solution. How much of each type was used? That's problem number 22 in the notes. But you know what? How many of us are going to be working with acid? Not a lot. That's a very specialized field. You know what? Let's change acid to the word alcohol. This is where you get alcohol at different proofs. So proof on alcohol, like 80 proof. Here's your learning for the day. 80 proof is 40% alcohol. That is a common like vodka or something like that. Let's say you had something where one was 20% and one was 50%. I don't know of any that come that way. There might be some beers that are at 20%, but I don't think so. Maybe wine coolers. I'm not sure. But I think this is more interesting with alcohol. The idea is that out of like a glass, whether it be alcohol or acid, only a certain percentage of it is an active ingredient. The rest is like water or something else. That like you don't get drunk on water. And you don't get melted by water unless you're a wicked witch. So like that's the idea of what's going on here. This proof thing is not related to the question. We're just going to work with this as alcohol. So I'm going to have alcohol X. Let's call it the weak alcohol and the strong alcohol. And we'll do amount. I'll use W for the weak and S for the strong. The rate or the percentage for the weak was at 20%, so 0.20. And the stronger alcohol had 50%, which would show up as 100 proof. So that's pretty good. That's a pretty good strength. A 20% solution is like taking 80 proof vodka and mixing it with equal parts water or like Kool-Aid or something. And then you wanted to mix it with something that's 100 proof. So then we got total quantity present, like the actual alcohol content present. There's only 0.20 times W, and there's only 0.50 times S, because these are multiplication. Just like the last one, we had a total. We don't know how many liters it was for each one individually, but we do know that they added up to 10. So W plus S should equal 10. And I don't know, like adding rates together doesn't make sense. But I do know when this was added together, I should have had a 30% solution. This solution was 30%. 10 times 0.30, this should be 3, which is 10 times 0.30. 10 liters at 30% is 3. All right. I add those together and I get 0.20, or I don't need the extra 0. 0.2 W plus 0.5 S equals 3. All right, what I'm going to do right away is I'm going to multiply. I can do an elimination method here pretty quick if I'm willing to work with decimals. S and 0.5 S are off by, this one's twice as much. You know what? Let's just clear decimals first. When you have one decimal in place, multiplying by 10 clears decimals. And I will get 2W plus 5S equals 30. And W plus S equals 10. I did substitution last time. This time I want to do elimination. So I will get equal and opposite coefficients. I'm going to choose the smaller number here. I'm going to multiply this by -2. This will give me -2W minus 2S equals -20. If I add these up, I get 3s equals 10. Oh, this is an ugly answer. So s equals 10/3 or 3 1/3. Then I could find w by plugging this into there. W plus 10/3 equals 10. And 10 is the same thing as 30 over 3. If I multiply by 3 over 3, I subtract 10/3. And I get W equals 20/3. Which means effectively 2 parts weak for 1 part strong. Because 20 over 3 is double 10 over 3. Does this work? 10 over 3 plus 20 over 3. Well, 20 over 3 was the weak. I'll put that first. Plus 10 over 3. Does that equal 10? I get 30 over 3 equals 10. That's true. 0.2 times 10 over 3. 20 over 3, sorry. Plus 0.5 times 10 over 3. Does that equal 3? So 0.2 is the same thing as 1/5. And 0.5 is the same thing as 1/2. So if I multiply this, I have 20 over 15 plus 10 over 6. Does that equal 3? So let's get a common denominator. 15 is 3 times 5, 2. The LCD would be 3 times 5 times 2, which is 3 times 10, which is 30. That shouldn't be a surprise. We had 30 for everything up there. So what I got to multiply by, I need to multiply by this by 2 over 2, and I need to multiply this by 5 over 5. I get 40 over 30 plus 50 over 30 equals 90 over 30, which does equal 3. So it satisfied both equations. So 3 1/3, and we basically have 6 2/6, or 6 2/3. All right. That was fun. Are you having fun? That was kind of long. That's 2 videos, or 2 of them. I'm going to make a second video for the second half. Break this up. These were on percent and money. The next one is on distance. Peace.